Hello, my name is Valentina Nikolova. I'm from the University of Mining and Geology in Sofia. I work in the Department of Geology and Geoinformatics, and together with colleagues from the department and also with colleagues from the Department of Mine Surveying and Geodesy, we are working on a project related about the application of geoinformation technologies in erosion research in mountain areas. So I will present shortly some results of our projects and data methodology. But first, I would like to say some words about the research objectives and the study area. The main purpose of the study is to analyze the morphometric properties of the topographic surface of the erosion slope and grain size statistical parameters of the sediment as an indicator for erosion processes and short-term change in erosion and deposition. The emphasis of the research is integrated application of geoinformation technologies and classical geomorphology. And in this study, classical geomorphology is highly supported by geoinformation technologies. The study area is a part of watershed of the river Bulgaria. It is situated in southern Bulgaria. This is a small watershed and with low population density. And in the first point of view, regarding the low intensity of erosion processes, someone could say that these processes don't have a strong effect, negative effect on the population and are not too important. But even in they occur in isolated areas, it is important to know about these processes because if some preventative and mitigation measures will not be taken, in long term, erosion processes could change the ecosystem as a whole, could change the sediment regime of the water. This small river Bulgaria flows directly into the Kırjali Dam, and in long term, it could affect the sediment regime of the dam and cause landslides or floods with strong negative effect. This is our study areas, and we studied in detail two small gullies located in the northern and in the southern part of the slopes, and the points indicate the soil sampling and of these samples we did grain size analysis. Here you can see some view of the study area. We put this wooden mark and to measure the erosion and deposition and to correlate this with models done from the data acquired by unmanned aerial system. If we consider the images from October 2021 and June 2022, we can see clearly parts of the flows on the image of June 2022. Actually, this image was taken after a few days after the heavy rain in this area. This is a part of the northern gullies and the low part of the gully where we can see changes of grain size parameters. I will say few words about that at the presentation later. Also here we can see clear part of the washed materials of the slope on June 2023. Regarding the study workflow, we can consider two main aspects. The first one is application of geospatial technologies, and the second one, classical geomorphology. Geoinformation approach contains topographic data acquisition using a managerial system, data processing, creating digital terrain models with high resolution, some derivative models like slope, topographic wetness index, and elevation profiles. And classical geomorphology is related in this research to sediment sampling, morphometric analysis, and grain size analysis. Both sub-workflows lead to conclusions about transport and deposition environment, and about changes in erosion and deposition. For photogrammetric purposes and for data collecting, we did two field campaigns, one in October 2021 and the second in November 2022. 20 points were placed on the terrain. They can be seen in this second photo, and we used 6 points as ground control points for georeferencing the model, and the other 14 points are used as checkpoints. As a result of field campaign, 368 images were obtained for each one of the campaigns. The data acquisition were done on one and the same way, and one and the same flight plan to be able to consider the changes in the surfaces. We use structure for motion algorithm in Agisoft Metashape professional software, and as a result we received dense point clouds. These dense point clouds were filtered further to receive ground points. Here you can see an example. This is the dense point cloud, and here is the filtered point cloud that where vegetation were removed. And we use this terrain data to do terrain models. Digital terrain models have been created in ArcGIS Pro environment using natural neighbor interpolation, triangulation method. We created two digital terrain models in different resolution, one of 5 centimeters and one with 1 meter resolution. These models were used for different purposes for creating the different products. 1 meter digital terrain models is used for creating surfaces of slope and topographic wetness index, and digital terrain model with higher resolution of 5 centimeters were used for analysis of cross-sectional elevation profile, on the base of which morphometric properties of the area were analyzed, and also the changes of topographic surface have been determined. On the base of the sampled sediments and soils, we did grain size analysis using sieve and aerometric methods, and the data processing was done in Gradistat software. This is open source software. We analyzed graphic mean size of the particle size, standard deviations, skewness, and kurtosis, and used well known in geomorphological and geological studies methodology for determining these statistical parameters using the cumulative curves, which were done from the fractions that we received as a result of grain size analysis. Actually, these parameters can be calculated using the formulas given in this column. They are based on the diameter of the grain size in different percentage of the curves. Regarding to the results, there are no visible changes in the surface of slope and topographic wetness index received from the data of the both campaigns. The patterns of the changes in the slope are very similar. A bit higher slopes are determined for the data of November 2022, which can indicate some changes in the erosion processes. The same is the results about topographic wetness index. Actually, this index shows the ability of the topographic surface to collect water, and it is calculated as a normal logarithm of the ratio between the specific contributing area and tangents of the slope gradient. And for specific contributing area, we used flow accumulation raster generated on the base of digital terrain models in ArcGIS environment. The differences between the surface of topographic wetness index received from the date for the data of October 2021 and November 2022 allow to determine points of accumulation, erosion, and no change. And the results show that in the northern gully, erosion processes were a bit clearly defined, and while in the other gully no changes or accumulation are predominant in the low part of the gully, and in the upper part, erosion processes are more active. This index also can be used for delineating of slopes and non-permanent slopes. If we consider cross-section topographic profiles generated from the digital terrain models, we can see some changes. Here are the profiles done for the northern gully. The first one from the upper part of the gully, and the second row shows the changes in the elevation profile in the low part of the gully. If we consider the details, the results in details, changes are more visible in the low part of the gully. And here is the elevation profile of the northern part, of the upper part of the southern gully, and elevation profiles in the low part of the gully. Here we can see that in the low part of the gully, lateral erosion is occurred for the period of 1 year between October 2021 and November 2022, and Also, we can see the changes in the minimal and maximal values of elevation, which are approximately 2 centimeters for 1 year period. Regarding the results of the grain size parameters, almost in all cases we can see poorly or very poorly or moderately poorly sorted materials, which confirm the non-permanent flow of the area and more and high dynamic of the environment regarding the transport and deposition conditions. Here, the best way to analyze the sorting is the sorting coefficient, but also skewness and kurtosis can be considered as second indicators of the sorting. It depends, for example, skewness can be considered as a measure of the proportion between coarse and fine fraction of the samples, and in this regards to give information about the sorting of the materials and the conditions, environmental conditions of transport and deposition. High values of sorting coefficient indicates more turbulent flow and intensive processes. Actually, alternation of dry and wet period in the area facilitate disintegration of slope materials, and in this relation lead to intensive erosion processes. And as a conclusion of the results, we can say that erosion and deposition rates of around 2 centimeters are observed from October 2021 and November 2022. These are average rates in different points. We observed low or high values. 5 centimeter cells size digital terrain models give reliable results for assessment of elevation profiles and analysis of the changes of the topographic surface. Topographic whiteness index gives better results using smoothed digital terrain models. All these parameters, I can say, are strongly related to the resolution of the model, and in this relation, future research have to be done in this direction and to test other areas to evaluate the applicability of the methodology and transferability of the results to different landscape with different environmental conditions. The sorting values are highly related to lithological composition and the rate of weathering. For this small area, the climate and meteorological conditions are important for the transport, the material and the accumulation, but they cannot give information about the changes between the different parts of the slope. In this relation, lithological composition and the rate of weathering of the rocks are more important. And in the end, I would like to acknowledge the project in the frame of which the research is done, and the project is funded by the Bulgarian Ministry of Education and Science. And as I mentioned, it is about application of geoinformation technologies in studying erosion processes in mountain areas. Thank you for your attention.
Thank you very much. Any comments from you? Yes, I could. Please.
Thank you. It is very interesting because it is important to know this mathematics part of our work, erosion and problems. And as far as I understood, you are implementing probably some kind of statistical model. Are you interested in prediction of these erosion parameters through this model